Hey guys, I hope you're all doing well. If there's a specific topic you want us to talk about, feel free to email us using the address in the description or our YouTube bio. You can send us anything, study guides, homework, PDF, or just topics you're curious about. We're here to help you learn for school or work, study for school or work, and relax. So please send us topics as we will go into further detail about them, hoping for you to get a better understanding. Now please enjoy the video and comment on where you're watching it today. I wish you all the best and enjoy.
Welcome, curious minds, to another deep dive. We're looking into the hippie side of something really familiar today. We're going to take something that feels wonderfully simple almost every day and really break it down.
Yeah.
Layer by layer. You know that sound, right? That fantastic snap when you break off a piece.
Oh, yeah. Instantly recognizable.
It just screams KitKat. So today, we're talking about the KitKat bar. Seems humble, but it's surprisingly sophisticated.
Absolutely.
On the surface, okay, chocolate is wafer, simple enough. But under that wrapper, under the logo, it's like a mini marvel of industrial design. Precision engineering, food science, it's all in there. Our mission today is to unpack how these things are actually made. We'll look at the surprising facts, the ingenious methods, especially how they get that consistent quality, that texture, everywhere in the world. And we're even going to uncover let's call it a secret ingredient, something that makes KitKats kind of unique and surprisingly sustainable too.
And it really is a global story, isn't it? Spans continents, generations. It shows incredible brand appeal, how adaptable the manufacturing is. It started with round trees in the UK, right? But now it's this huge phenomenon. Nestle owns it pretty much worldwide.
Except in the US.
Except the US, yeah, that's Hershey territory under license. But even with different companies involved, the core thing, that multi-layer wafer, the crispness, the milk chocolate, it stays remarkably consistent.
That's the amazing part.
It is. And this deep dive, I think it'll really show how they manage that consistency across huge production volumes, different regions. It's quite a feat of engineering, really, and supply chain management, too.
Okay, let's unpack this then. When we think KitKat, chocolate and wafer come to mind. But even those words hide a lot. What's actually in that KitKat chocolate? The coating. What gives it that specific taste, that texture?
That's the perfect place to start because every ingredient, honestly, it's chosen for a very specific job. So that milk chocolate coating, it's way more than just cocoa. You've got a precise blend. There's sugar, obviously, for sweetness and just bulk. Then cocoa butter, that's the fat from the cocoa bean. Super important for how it feels in your mouth, how it melts. And chocolate liquor, or cocoa mass, some call it. That's basically ground cocoa beans, gives you the core chocolate flavor. Then whole milk powder, very important. That's what gives KitKat its signature creamy, milky taste, makes it different from, say, dark chocolate.
Right.
And then to make sure all that blends together smoothly, they use lecithin.
Lecithin, I've seen that on labels. What does it actually do?
It's an emulsifier. Sounds technical, but it basically helps the fat and, well, any tiny water bits, say, mix together properly in the chocolate. Without it, the chocolate could get too thick or gritty, might even separate, which would make it really hard to get that thin, even coating you need for KitKat's crispness. Lecithin kind of makes the melted chocolate flow better, more smoothly.
So it helps with the coating process itself.
Exactly. Helps it spread evenly during what they call enrobing. And finally, for that classic smell and taste, there's vanillin. It's an artificial vanilla flavor.
Why artificial?
Well, natural vanilla can vary a lot in flavor, and it's much more expensive for the kind of scale they're working at. Vanillin gives them that consistent flavor profile people expect from KitKat, reliably and cost-effectively.
So lecithin isn't just filler; it's actually engineering the chocolate flow. That's fascinating. But like you said, chocolate's only half the equation. What about the wafer? That incredibly light, crisp wafer? How do they get that texture?
Right, the wafer. It's a marvel in itself.
Yeah.
The main structure comes from wheat flour, for the gluten. Then they use specific fats like palm oil or maybe sunflower oil. These aren't just for richness, they really help create that crisp texture, and they also help stop the wafer getting soggy later on.
Okay.
Then, crucially, you have leavening agents, specifically baking soda, sodium bicarbonate, and ammonium bicarbonate.
What do those do differently than, say, yeast?
Well, they're heat activated, so when the batter hits the hot oven, these compounds break down and release gases. Carbon dioxide, ammonia. These gases create loads of tiny air pockets all through the wafer.
Ah, like little bubbles.
Exactly. That's what gives it that incredibly light, airy structure, makes it different from a dense biscuit, you know?
Yeah, definitely.
Then there's a bit of salt for flavor balance, water, obviously, to make the batter. And they actually put more milk powder in the wafer, too, for flavor and a bit of creaminess there. Plus some sugar, which helps with browning and adds a little sweetness.
So it's a really carefully balanced recipe, each part doing something specific.
Absolutely. Every ingredient plays a role in getting that signature KitKat wafer. It's the foundation, really.
It sounds like this precise chemical dance even before baking starts. So once they've got this perfect batter, how does it become those super thin, uniform wafer sheets? What's that initial production look like?
It is a dance, yeah, but on a massive scale. The first big step is making the wafers. It starts with batter mixing. They create this light batter, maybe like a thin pancake batter consistency, using those ingredients we just listed. And quality control is huge here. The consistency, viscosity, aeration, it all has to be just right.
Any small change would affect the final wafer, I guess.
Totally. So once the batter's perfect, it goes to sheeting and baking. It's not poured onto a flat tray. It goes onto a continuously moving belt. This belt passes over heated rotating drums, or in the really modern plants, special wafer plate ovens.
Like a giant continuous waffle iron, but flat.
Kinda, yeah. But designed for these perfect thin sheets, these ovens can be huge, like meters long. And the baking itself is super quick and precise. It's real thermal engineering. The batter hits about 180 degrees Celsius, that's 356 Fahrenheit.
Huh.
At that heat, with the leavening agents kicking in, the thin batter layers bake incredibly fast, maybe just 2 minutes.
2 minutes, that's it.
That's it. This rapid, hot baking is key. It makes the sheets golden, super crisp, but without drying them out completely or making them too brittle. The heat has to be perfectly even across the whole sheet, too.
And then they're ready.
Not quite. Straight after baking, they need to cool. They move on to these long, rotating conveyors. They cool down gradually, which helps stabilize that delicate structure.
Why is cooling so important?
It's critical, often overlooked. It locks in the crispness. If they handled them warm, they'd be too soft. They'd crumble, lose that texture. Cooling makes them firm enough for everything that comes next. The layering, the cutting, the chocolate.
So that initial wafer process batter, baking, cooling, sets the stage for everything else.
Yeah.
Consistency is key right from the start.
Absolutely. Every single sheet needs to be identical in thickness, color, texture. Otherwise, the whole layering and cutting process just wouldn't work smoothly.
Okay, that's way more complex than I thought for just a wafer. So we've got these perfect, crisp sheets. Now, this is where it gets really interesting, and maybe a bit mind-blowing for some people. What is actually between those wafer layers? And what's this sustainability trick you mentioned? Because when you bite into a KitKat, you feel the wafer. Yeah, but there's that creamy filling separating them. And it's not just chocolate cream, is it?
No, it's not. This is where the real KitKat ingenuity comes in. That unique filling, that creamy paste between the wafers. It's actually made from crushed, unsellable KitKat.
Wait, really?
Yep. Recycled broken bars right off the production line. They get mixed with chocolate to make that paste. So KitKats are quite literally made of KitKats.
That's amazing. But why? Is it just cheaper?
It's partly efficiency, sure, but it's more than that. It's incredibly innovative. It's not just about texture. It's a serious commitment to sustainability, reducing waste. It's like a mini circular economy inside the chocolate bar.
Wow. A circular economy in a candy bar.
Exactly. And it's fascinating how they nail both texture and sustainability with this one step. This recycled filling secret is, well, pretty well known in the food industry now, and for good reason. It embodies that whole waste as a resource idea. It starts with what they call factory damaged KitKats. bars that don't quite meet the super strict quality standard.
Like they're broken or the logo's messed up.
Exactly. Broken bars, maybe the chocolate coating isn't perfect, maybe they're slightly off weight. Instead of just chucking them, which would be a huge amount of waste, given how many KitKats they make, they collect all these imperfect ones.
Okay.
Then they grind them down into this fine, crumbly paste. But it's not just reused scrap. They carefully blend this paste with fresh chocolate, a bit more cocoa butter, maybe some vegetable oil, to create what's officially called the wafer cream, or filling.
So it's a specific recipe using the recycled bits.
Precisely. They're transforming waste into a high-quality ingredient designed for the bar's texture and flavor. The purpose is twofold. First, obviously, waste reduction. Big tick for sustainability goals, something Nestle talks about a lot. It's a really clever way to handle production line imperfections.
Makes sense.
But second, this filling is crucial for the feel of the KitKat. It adds that creaminess between the crisp wafers, stops it feeling too dry or brittle.
Ah, right. It balances the crispness.
Exactly. Which leads us to the layering. Once those big wafer sheets are cooled and stable, they hit the layering stage. High-speed conveyors, automated machinery, often robots.
Wow.
Yeah, they alternate layers of wafer sheet with layers of this special wafer cream paste. A standard KitKat usually has, 3 to 5 wafer layers, each separated by this creamy filling. The thickness is tightly controlled.
So you get that consistent ratio in every bar.
After stacking, they form these big multi-layered blocks. Then they get lightly pressed, not crushed, just enough to bind the layers together, get rid of air gaps, make a nice, dense, uniform stack, which is vital for the next step, cutting.
Okay.
But before cutting, they go into a chilling tunnel. This is super important. It sets the cream filling quickly, makes it firm.
Why firm?
So when they cut it, the cuts are clean and precise. If the filling was soft, it would smear, the wafers might crumble, the layers could shift. You wouldn't get that nice defined structure.
Gotcha.
And as we said, that creamy layer also stops the whole bar feeling too dry later on. It helps maintain a certain softness, contributing to that overall mouthfeel, that perfect, crisp, creamy balance. That is KitKat. It's not just filler, it's engineered texture.
Okay, so we've got these huge chilled blocks of layered wafers and cream. Giant KitKat sandwiches, basically.
Okay.
How do they become the individual fingers we recognize? This must be where the precision engineering really kicks in.
It's a pretty cool transformation, yeah. It relies on seriously sophisticated cutting tech. After chilling, these big blocks, they can be several feet long, move into a cutting chamber. Inside, you've got banks of high-speed, ultra-precise blades slicing them up into the exact bar sizes. Often, they use ultrasonic blades.
Ultrasonic, like vibrating really fast.
Thousands of times a second, yeah. The vibration lets them cut cleanly through both the crisp wafer and the firm cream without crumbling or sticking. It's very neat. The blades are shaped to create that iconic finger shape, too. The rounded top, flat base, all within tiny tolerances.
That precision must be vital for wrapping later, too.
Absolutely, for the coating, for packaging, everything.
And you mentioned waste again. What happens to the offcuts here?
Right, here's that circular economy thing again. Any little trimmings from the cutting the edges, any bits that aren't perfect shape, they don't get tossed, they go right back into the system.
Back into the paste.
Exactly. Back into the recycled filling mix for future KitKats. It's a beautifully efficient closed loop. They maximize material use, minimize waste at pretty much every stage. It's really quite brilliant.
That is clever. So now we have perfectly cut wafer fingers. Next up must be the chocolate coating.
Yep. And the chocolate enrobing, connecting it to the bigger picture, isn't just about taste or looks. It's crucial for texture, stability, even shelf life. It starts with tempering the milk chocolate.
Tempering. I've heard that term with chocolate making. What does it actually involve?
It's super important. It's what separates pro chocolate work from home baking sometimes. It's a very precise heating and cooling process, done in stages. Typically, you heat the chocolate to about 115 Fahrenheit, maybe 46 Celsius. That melts all the different types of cocoa butter crystals. Then you cool it fast, down to around 80 Fahrenheit, 27 Celsius. This encourages the right kind of stable crystals, beta crystals, to form. Then you warm it back up slightly to about 88 Fahrenheit, 31 Celsius. That's the perfect working temperature where only those good stable crystals remain. Have to keep it moving, agitating it too.
Why go through all that? What does tempering actually do for the chocolate?
It's crucial. It stabilizes those cocoa butter crystals. If you don't temper properly, you get bloom. That's that dull, grayish, streaky look chocolate sometimes gets, caused by unstable fat crystals messing things up.
Right, I've seen that.
More importantly for KitKat, untempered chocolate wouldn't have that firm, clean snap. Tempering gives chocolate its shine, its smooth texture, that sharp break, and it makes it less likely to melt too easily at room temperature. It's delicate, but essential for the KitKat experience.
Okay, so the chocolate is perfectly tempered. How does it get onto the wafer bars?
Right, so the individual wafer fingers move onto a mesh conveyor belt. First step is the bottom coating. They pass over a roller or curtain that applies a precise layer of tempered chocolate just to the base. Then, immediately after, they go through the full enrobing. This is quite a sight. Imagine continuous waterfalls or curtains of tempered chocolate pouring down from above.
Wow.
Hundreds of gallons flowing constantly. The bars pass underneath and get completely coated, top, sides, everything. The flow rate, the temperature, it's all tightly controlled for the perfect coating thickness.
How do they make sure it's smooth, no bubbles?
Good question. As they come out of the enrober, the belt gently vibrates. This does two things. It helps the excess chocolate drip off evenly, and it shakes out any trapped air bubbles. You don't want bubbles messing up the finish or creating weak spots.
Smart. And then it needs to harden.
Yep. Into the cooling tunnel. Highly controlled temperature, usually around 50 Fahrenheit, 10 Celsius. The bars travel through for maybe 5 to 10 minutes. This lets the chocolate set hard uniformly. Gives the bar its structure, that nice sheen. Cooling too fast or slow could ruin it.
And the logo. When does that happen?
The iconic logo. This needs perfect timing. As the bars come out of the cooling tunnel, the chocolate is setting, but not totally rock hard yet. That's when metal embossers press the KitKat logo onto the top of each finger.
So it has to be firm enough to hold the shape, but soft enough to take the imprint.
Exactly. Firm enough to hold the crisp logo, soft enough not to crack or crumble. It's that final touch, crucial for the brand. This whole process from batter to logo, it's just relentless attention to detail. That's what makes KitKat KitKat.
It really is incredible, all that precision. So, okay, they're made, but how do they guarantee that every single KitKat, whether I buy it here or, somewhere else entirely, gives that same satisfying experience? What about that snap we keep talking about? Quality control must be intense.
Intense is a good word. Consistency isn't luck. It's constant checking. It starts even before ingredients arrive, with strict specs for cocoa, flour, everything. Then during production, multiple checkpoints. You've got visual inspection. Nowadays, that's often high-tech. High-res cameras, AI, machine vision systems scanning every single bar.
What are they looking for?
Tiny flaws. Cracks in the coating, wafers off-center, melted edges, logo imperfections. These systems can spot things a human eye would miss super fast.
Wow.
Then there's weight and dimension checks. Sensors scan each bar. Is it the right weight, right size, down to fractions of a gram? If anything's off, it gets diverted.
And thrown out.
No. Again, cleverly, those non-spec bars usually get recycled back into the wafer cream filling. That closed loop system again.
That's really impressive. Is it all machines, though?
No, there's a vital human element too. Random sampling. Workers pull bars off the line regularly. They do taste tests. Is the flavor right? Sweetness, chocolate notes. They check the texture. Is the wafer crisp? Is the creaminess right? And famously, they do the snap test by hand, listening for that clean, sharp sound. It's this mix of high-tech automation and skilled human checks that maintains that global quality standard.
That makes sense. So the snap test, we started with the sound. Why do KitKats snap so well? You said it's engineered. How?
Yeah, it really is engineered. It's a key part of the whole sensory thing. Two main reasons. First, the wafer structure. Think of it like rigid internal scaffolding.
Scaffolding.
Yeah, those thin, crisp layers baked just right, cooled perfectly.
Yeah.
They create this internal lattice. It gives the bar strength in one direction, but makes it easy to break cleanly along the scores between the fingers. The structure guides the fracture.
So it breaks where it's supposed to.
Exactly, rather than just crumbling. And second, back to the tempered chocolate, we talked about those stable beta crystals. That specific crystalline structure makes the hardened chocolate quite brittle in a good way. When you apply stress, like breaking off a finger, That uniform structure fractures cleanly, and that clean break creates the distinct sound, that satisfying snap. It's material science in action.
Wow. Engineered sound.
Pretty much. And beyond the snap, the overall texture, the melting point, it's all carefully controlled too. That creamy layer inside, the recycled filling, it's not just waste reduction, it stops the wafer feeling too dry, adds that little bit of chewiness, that contrast.
Right, the balance.
And the chocolate itself, it's designed to melt right around body temperature, about 98 Fahrenheit, 37 Celsius.
Why that specific temperature?
Because that's when you get the best flavor release and mouthfeel. It melts smoothly, coats your palate, releases all those chocolate notes perfectly, gives you that luxurious feel, complementing the wafer's crispness. It's the whole package, texture, temperature, sound, all designed.
Okay, so we've really peeled back the layers on how they're made. But KitKat is global. Are they all exactly the same everywhere? And what about those crazy flavors you hear about?
That's a great question. Because no, they're not all identical. The biggest difference is probably the US versus, say, the UK or Japan.
Because Hershey makes them in the US.
Exactly. Hershey uses a slightly different chocolate recipe than Nestle does globally. Often, the US version might have a bit more milk, more sugar. It gives it that sweeter, maybe creamier taste that many Americans prefer, that sort of Hershey's chocolate profile.
Whereas the Nestle one is...
Still milk chocolate, but maybe a slightly different cocoa balance. So the taste, the melt, the mouthfeel, it can be subtly different depending on where you buy it. They adapt to local tastes while keeping the core idea.
Which brings us to Japan. Because the flavors there sound wild.
Oh, Japan is the ultimate example of adapting the core process for creativity. It's incredible. We're not talking just a few special editions. Since 2000, they've had over 300 different KitKat flavors in Japan.
300.
Yeah. It's a whole cultural thing there, and the flavors are just mind-blowing. Really imaginative, often using local ingredients.
Like what? Give me some examples.
Okay, get this. Wasabi KitKats.
No way. Spicy.
Got that savory kick, yeah. Sake KitKats using Japanese rice wine flavor. Matcha green tea, obviously, that's huge. Baked sweet potato flavor. Cheesecake, cherry blossom for spring, regional ones like Hokkaido melon, even soy sauce flavor.
Soy sauce. In a KitKat.
Yep, the innovation is constant. People there wait for the new releases.
But how do they even make those? Is it the same process?
Fundamentally, yes. That's what's so amazing. They use the same basic engineering, wafer making, the layering with that cream filling, the enrobing, the packaging. What changes is how they incorporate these unique Japanese ingredients and flavor profiles.
So they flavor the chocolate coating.
Yep.
Or the cream inside.
Both, potentially. The food scientists there have to be incredibly skilled. They need to make sure these new flavors work, taste good, and don't mess up the texture, the snap, the shelf life. Imagine adding wasabi powder. How does that affect how the chocolate crystallizes? They have to figure all that out. It shows how robust that core KitKat manufacturing process really is.
That's incredible flexibility.
And it's driven by culture, too. In Japan, KitKat sounds like kitokatsu.
Which means...
Roughly, you will surely win, or good luck. So KitKats became these popular good luck charms, especially for students taking exams.
Ah, so people give them as gifts.
Exactly. They exchange them for good luck. So Nestle leans into that with special exam